we introduce a new feature called show IP rib, and we enhance the show IP route. So this is a very good enhancement thanks to the work that has been done for the usability from the usability team. So the agenda will cover well, the overview of those commands, the obvious use case that we have that are troubleshooting details, and then we go through demonstration. So let's start with some acronyms. So routing table. Routing table, this is, I would say, a list of valid routing entries that are selecting from each active routing protocols. And that collections of selection, that collection of selected entries is based on the administrative distance for each of those protocols. So this is the routing table. Then we have the FIB, the forwarding information base, which are the active forwarding entries that are configured and programmed into the ASIC based on the information of the routing table, the selected routes that we had before in the routing table. And then you have the RIB, the routing information base, which is pure software, which is not only the selected routes, but as well the non-selected candidate routes per routing protocols. So this is really important to understand the difference between RIB and FIB. So FIB, and the routing table. So the routing table is software, FIB is in hardware, what you have, and RIB is a superset of routing table. It's equal to the routing table plus the non-selected candidate routes per routing protocol. Routing table manager. It is responsible to maintain the routes, the best routes selected for each routing protocol, so for BGP, for OSPF, with the various attributes of that route, and put that in a table that is called RIB. And then that component is also responsible to determine the best route for each destination, so to elect the best route and to program that information into the FIB. And it will program that entry in and pass that over through the OSDB to the FIB app daemon that I explained to you. So the use cases. When should I use the RIB new command? Obviously, during a routing troubleshooting session where you have several candidate next hops for the same route competing with different administrative distance. So as an example, I've got 10.1.0.0/16 that is known from internal BGP and from OSPF. Well, internal BGP admin distance is 200, OSPF is 110, OSPF will win. But it's still, it might be very important to know that you learn that by internal BGP. So having that information from the RIB is very interesting in order to, for instance, to understand what will happen if there is a link failure or a path failure. Then I know immediately that this route would be already known from an alternative routing protocol. The use case for enhancing show IP route, well, mainly the usability requests that we've seen in the past year. So we improved the tabulation. We have now the interface information from the next stop reachability, the route type details for OSPF and even for BGP, the age of the route, clear tag information now. So this is really that in the detailed slide that you will see in a while. Everything, all the platforms. So this is platform independent. So we have that support for show IP RIB, show IPv6 RIB, and the enhancement of show IP route and show IPv6 route on all the platform as of 10.7, the first release, GA mid-April. So let's consider that new command, show IP RIB. You will see it's extremely similar to the show IP route. There is only two new options, which is what I was mentioning, selected and non-selected. With keyword selected, the show IP RIB will be almost equal to, or will be equal to a show IP route. And show IP RIB non-selected will provide you the information that are the routes, candidate routes, not preferred and not put into the FIB. In the slide deck, you will see obviously the IPv6 version of what I previously explained you to IPv4. So I will go quickly over those slides for IPv6. So before 10.7, just as a reminder, when you do a show IP route, you have the routes that are listed here. But obviously, we can say that the presentation and the display of that output of the command is not so perfect. So the same for IPv6 here. So we improve that, and this is now what we have as an improvement. So first of all, you see the tabulation. So this is nicely displayed with columns. You see the interface for the next hop reachability. Here, if you do some route leaking, you have the VRF egress that was already present in the previous command, but here nicely displays as well. You have the route type, for instance. Here you will see OSPF, that's an external route type 2. External type 2 for SPF. You will see the age, and that information is very much important when you want to troubleshoot, for instance, link flapping or issues with a given routing protocol. So that information is very, very useful for troubleshooting. I will go back to that topology that I show you here in the show IP rib. We will use that to explain you. So this command is done from that switch 1 here. And what I construct with that topology is typically where I've got a route, same route learned from 2 different routing protocol to see that non-selected routes. For IPv6, it's exactly the same. Okay, so I know that some of you may say, well, how you display the long prefix in IPv6? So this is nicely displayed here when it's regular, short, I would say IPv6 prefixes. But obviously we have some improvement to be made when we have some longer prefix. So that is currently being investigated, and stay tuned on that. We'll have probably some improvement as well on the longer prefixes. So the RIB display here. So as I mentioned, so let's take a little example on the top right here. So what I'd like is to make sure that I've got routes that are learned on a given switch with 2 different protocols, so that I can see that there is one route that will be selected and one route that is not selected. So what I did is simple. Here on switch 3, I've got a subnet that is connected, right? And this subnet is redistributed in OSPF, so it's learned through OSPF. So switch 2 is learning it and sending that to switch 1. So switch 1 will learn that subnet with OSPF. And here between switch 1 and switch 3, there is no OSPF, but there is only, I would say, BGP. So in that case, what we do have is that destination is learned by BGP and is learned by OSPF. So this is why here you have a star. So the dark blue indicates the preferred selected route from BGP, and the light blue is showing the candidate, but that is not preferred. So, but still you have that information. And if you do a show IP read non-selected, you'll get the list of all the routes that were the best, I would say the best route for a given routing protocol, but not selected due to another routing protocol winning and having the route populating in the FIB through this other protocol. So if you do a show IP rib selected and show IP route, you should pretty much having the same level of information. For IPv6, this is exactly the same principle. Okay, so you will also see in IPv6 the non-selected route. And as well for IPv6 route, you may you will see that show IPv6 rib selected will provide you the same output than the show IPv6 route. There is a corner case where those routes are for destination being behind the VXLAN remote VTEP, where you will see a difference. Next up for IP route will be IPv4 tunnel interface, and for the RIB it will be the local, the link local IPLS. But that's a very corner case. So some caveats about the RIB. So the counts that you have, the route counts in the RIB, will include the prefix that are displayed multiple times, the prefix that are not selected, right? So the total number of counts would be higher than if you do a show IP route. The dumped routes will not appear in the RIB because these are not route that would be selected for any protocols, so they are not programmed in the FIB, and they are not showing in the RIB. So we ask R&D if we can have that particular feature as enhancement. It might be for a future release. So route edge, we talk about that. This is important to identify route flapping or link flapping between equipments. A note about large scale: if we have a lot of routes to display, that command might be long. There is improvement ongoing to reduce that time to display the show IP RIB. When we do a show IP RIB, the table is constructed live. So it means that there is no, I would say, any resources that are maintained or like a memory, a dedicated memory to store those informations, as this is immediately cleared when the command is ended. So this is there is no no resource being consumed permanently for showing non-selected routes, for instance. You will see that this RIB is available in Swagger in OpenAPI specification, but the API is not yet supported. So if you try a call on that one, you will get no answer. Here we compare the before for a given prefix, before 10.7 and after 10.7. If you do a show IP route for a given prefix, you see, for instance, here the information, but now the improvement with tabulation. You have the age, you have the tag that is nicely displayed here. Before it was there, and you have the here, for instance, the OSPF route type. For V6, it's exactly the same. Here, just a matter of explaining details for EVPN route type. You still see the same level of information, but I would say cleanly displayed. Here, the encapsulation type, when you want to reach a subnet that is behind a remote VTEP, it's VXLAN, and you have as well the encapsulation detail, which is the layer 3 VNI. So the same than before, but again, displayed in a better form. The difference between show IP route and show IP RIB for a given prefix is whether the route is selected. So you have that information. It would be selected true or false. And you have as well if you need to do a recursive next up lookup to find the interface, for instance. So typically this would come for internal BGP, where you're peering over the loopback and you want to have, you need a recursivity and you need a lookup to analyze what interface would be to reach the next hop. So typically that information would be for a destination route that point to the next hop, and then you need to look for the next stop reachability through, for instance, OSPF to determine which interface the traffic needs to go. Showing IP route and IP RIB for ECMP routes. So here in my example, I've got a subnet here. So that is 192.168.4.2/31. That is known inside OSPF, and that is as well known from BGP. And it is known behind switch 1 and behind switch 3. So how switch 2 is going to receive that information is going to receive that through OSPF adjacency from switch 1, as well from switch 3. And on top, it will receive the information with BGP of switch 1. So in terms of route, it's internal BGP, so less preferred than OSPF. So in terms of route, you have twice OSPF in order to learn that. So you will have an ECMP route with 2 next hop. Okay, so nicely displayed here, right? And for RIB, you have three possibilities, 3 options, but actually only 2 are valid because you have selected true for the 2 routes ECMP corresponding to OSPF. And you can see for BGP, internal BGP, you have a recursive next hop true here. And finally, you have the RIB summary, okay, where you have the total list of routes. So with that, let's jump to a quick demo. So we have OSPF between switch 1, 2, and 3, and BGP between 1 and 3, BGP between 1 and 2. You have the short extract of the configuration on the slide if you want to make a mock-up on that one. So here on my switch 1, I've got you see, if I do a show IP route, I've got this particular route here, 10.2, which is provided and advertised by switch 3. So let me just show you how I did that. On switch 3, I've got an interface that is attached to that subnet. Okay, and that interface is part of OSPF. So OSPF LSDB is populated with that subnet, and we have as well redistribute connected here in BGP. So here I've got a show BGP IPv4 unicast where I've got this route here. And if I do a show IP RIB, you see this route here that is known because of BGP advertisement and with OSPF. So that's where I know what is the, let's say, maybe the alternate route if that BGP route disappears. So that would be that. I can do the same for IPv6. Where I have here this particular route, FD0010:2, which is the same but with IPv6. And if I do a show IPv6 RIB, I have it as well here. ECMP, so I can quickly take a look at this subnet here. So that subnet between switch 1 and switch 3. That subnet is 192.168.4.2, and on switch 3, you have this subnet that appears here with 2 next hop. If I want to look in particular for that destination, I've got nicely displayed the ECMP. And if I do show IP RIB for that one as well, I've got what I explained to you before.